And those questions are 5.3, 16/2. 5.3, 16/2.
Hey, Hubert, can I send you this other question?
Say again?
Is it okay if I send you this other question? I was able to figure out the first section. I'm just having trouble solving the second part of it.
Yeah, just go ahead and send it.
All right, thank you.
Okay, now this question is not a test question. It's a thinking question. It's one of those questions they want you to think. And it says f of t is equal to 5 and the real number, well, I'm gonna change those two numbers. Let's go with, because I've already done this problem and I did it with 6 and -4. So I want you to change those two numbers to 6 and -4. Consider the function f of t is equal to 6 and the real number a is equal to -4. A, they want you to find a of x is equal to a to x, antiderivative f of t dt. And then B, they want you to find a prime of x. Okay, first of all, does this have anything to do with you being able to find the antiderivatives on my test? No, it doesn't have anything to do with that. Okay, so that's how much weight this question has. It's one of those Wimbledon questions. So, first thing you're going to do is you're going to find out, the area of a rectangle is equal to base times height. So area of a rectangle is equal to base times height. So you got to find the base and the height. Okay, the height is equal to 6. Okay, because it says in the question that f of t, equal to 6. All right, f of t, it's like f of x. I don't know why in the hell they can't just say f of x. But anyway, they do everything they can to confuse you on some of these homework problems. So f of t is equal to 6. That's the same thing as saying y is equal to 6. So the height is equal to 6. Then what's the base? Well, this technically is your horizontal shift, but you got to plug it into the x minus h horizontally, and that's the negative right there. And we always said that a negative was opposite, so that would be x minus a -4, and that is your base. So your base is equal to x plus 4, and your height is equal to 6. So a of x, which is your function, a of x is equal to 6x plus 24. There's your function. Now there's two things you can find with this function. Go ahead and find the derivative and the antiderivative. Do that for me. Give you a minute. Okay, I'm going to tell you what, I don't really care about all the stuff this question's asking for, but a prime of x is equal to 6, and the antiderivative of 6x plus 24 is 6x squared over 2 plus 24x. And you can simplify that. That will be 3x squared plus 24. And that's the antiderivative. So, you know, the only thing I care about is these two things. I really don't care about everything they're asking about. And it's differentiable because we just took the derivative. It is continuous because it's a straight line. This right here is a straight line, so it is continuous. Okay, so now how this has anything to do with what I care about, I don't know, but that's how you do this problem. Okay. So there is a of x. A of x is 6x plus 24. And a prime of x is equal to 6. And that's b. And I think they ask you if it's differentiable. Well, if you can take the derivative of it, it's differentiable. So we just took the derivative of it. And if it's continuous, it's a straight line. So it is continuous. Again, it's not detrimental to being able to take the antiderivative. It has nothing to do with the antiderivative. So you figure it out. I have no idea why they're even asking it. But anyway, does that help you, I hope? I hope. All right, let's look at the next question. The next question is 5.3, 64, 8. 5.3, 64, 8. Now this one seems like a test question. Yeah, just ignore all this. There's the function. Y is equal to negative x squared plus 49, because nobody ever writes it like that. I have no idea why people write it like this. That's not the way to write it. But anyway, what are you going to do? Well, you got to read the directions. No. What's the first thing you're going to do with this problem? Somebody tell me. Okay, why have I only got 12 people on video, but I got 17 in the class? Okay, turn your damn videos on. I'm sorry, but you don't talk to me. At least turn your videos on. Turn them all on, or we're not going any further. We're just going to sit here and look at each other. Let's go. Turn them on, please. Okay, I'll go down the list and see who doesn't have them on. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to go down the list. Okay, Benson. Let me see if I can see Mr. Benson. There's Mr. Benson. Dosher. Where's Dosher? There's Dosher. Hafner. Where's Hafner? Hafner's right there. Hommerding. Where's Hommerding? There's Mr. Hommerding. Jackson. There you are. Thank you. Lee Croy. Yeah, it's amazing. I get people turning them back on now. Lee Croy. Mike, Michelle. Parker's there. Reed. Roberts is here. Sequoia. I saw Sequoia a while ago. There he is. Silva's here. Smith. Caleb. Thomas here. Wooten. Where's Wooten? Okay. Now, isn't that special? Leave them on. All right. Now, as I was saying, this is a test question. What's the first thing you're going to do with this problem? Let's say you don't have any idea. Let's say you don't have any idea how to do the integration or derivative. What's the first thing you're going to do with this problem? Number one rule of math. You need to graph it because you don't know what it looks like. So when you graph it, you know it's going to be a circle. It's going to open downward. And it's going to look like this. Got a y-intercept of 49. What's the x-intercepts? Somebody give them to me.
Would it be -7 and 7?
Good job. And what section are we on now? We're on antiderivatives. And somebody tell me what the antiderivative gives you. We've been studying it for the last day or two. I mean, yesterday I gave y'all all the questions on counting boxes. What are you doing?
You're finding the area under the curve.
Area under a what?
Under the
curve. So I can guarantee you they want to know the area under this curve. And I haven't even read the directions. Somebody tell me what's unique about this function. What's unique about this function?
It's symmetrical.
Is it that it's
It
downward?
is symmetrical. And 5.3 and 5.5 talk about symmetrical. And I don't know how to spell symmetric, but it looks good, so I'm going to say that. Symmetrical. That means that this is the mirror image of this. So there's three ways to set up this antiderivative. Can somebody give me one of the three ways to set up this derivative? Anybody? All right, well, the first way is to read from left to right. -7 to 0. -x² plus 49 dx plus 0 to 7 of -x² plus 49 dx. That's number one. Somebody give me another way to do the area under this curve.
Break it up into blocks.
Okay, articulate in volume. What?
Break it up into blocks.
Like what? Oh, yeah. Okay. Okay. I'm not talking about geometrical algebra. These are all calculuses. Okay. All right. I think you were doing what we were doing yesterday. Okay. Break it up into blocks and do the geometry. Yeah. That's not what I'm talking about. When I say three different integrals. Okay. I just did the first integral. Give me another integral I can set up for this problem. There's three integrals you can set up. Somebody give me another one.
Would it be -7 to 7 and then -x² plus 49 dx?
Yep. And somebody give me the third.
0 to 7. -x² plus 49 dx.
And do what after that?
Add -7 to 0. -x² plus 49
No.
dx.
You got the area from this side. What do you do with it? Multiply it by what?
Multiply it by 2.
2.
Those are the 3 ways. So I want you to write those down because I don't care which one you do, and neither does the book, because you will come up with the same what? Answer, because they are symmetrical. This is symmetrical. It is an even. It's an even term, so it's symmetrical around the what axis? It's symmetrical
Y-axis.
around the y-axis, so therefore you can do this. Now, if it's odd, it's symmetrical around the origin, which you will have a negative area and you'll have a positive area. I'm going to go with this one. Why am I going to go with this one down here? Why am I going to go with number 3? Anybody know?
It's the simplest one.
It's the easiest one. Tell me why it's the simplest one.
The 0 will cancel out.
Because the
second
0
part.
will cancel out and you got a positive number to run through it. That's the one that you're going to be told to use. You can use all 3 of them, but I'm going to use that one. So here we go.
Yeah,
Yes.
how did you get the radius? Did you graph it and use your graphing to find the radius, or did you just take the square root of 49 and that is the radius of the...
How did I get the x-intercept?
Yeah.
I just solved for what do you do to get your x-intercept? Plug in 0 for what?
For y. And then you just solve for
And
it.
what?
And
Solve.
take the x over, then square. Okay.
Solve.
Okay.
Now-
I just wonder if we graphed it to find the
Okay,
x.
yeah, that's it.
Okay, thank you.
That's how you do it. You just, that'll be negative 49 is equal to negative x squared. Divide by negative 1. X squared is equal to 49. And that'll give you your negative and your positive 7. All right, so here we go on the next page. And of course, Mr. Secoy, you would do that with your graphing calculator if it was more complicated and just do a trace and find your x-intercepts. If it was more
Yes, sir.
complicated, like a decimal or a radical or a fraction, you would just do that.
Okay.
Oh, this right here, this drawing and this number 3 right here, this is a test question. I'm not going to ask you to do number 1. You could do number 2 if you wanted to, but I'm going to ask you to do that's a test question right here. So, antiderivative from 0 to 7 of negative x squared plus 49 dx. This is my height. This is my base. So now I'm going to find it. And that's going to be negative x cubed over 3 plus 49x evaluated at 0 and 7. So I'm going to rewrite the big set of parentheses. And since this means evaluate and subtract, evaluate means plug and chug. That's what that blue line means. That blue line means you're going to plug and chug and you're going to evaluate. You're going to subtract. And your big number is the 7. That's what you're subtracting from. And your red number is what you are subtracting from the 7. So plug and chug, 7, 7, 0, 0. And take our red pen, and we all know what happens here. This goes out to 0. So you're left with this, and that comes out to be, what did I get? Y'all check me. I got 457. Oh, don't forget the 2. Don't forget that. I'm going to put that in pink. Don't forget to multiply by 2. And I got 2 times, let's see, what did I get? I got 228. No. Yeah, close enough. Somebody multiply 228 by 2. What do you get? 550.
457.
I'm sorry, what?
I had it as a decimal. I had it at 228.67. But then it kept
228.67. That's it.
Yeah.
And that turns out to be 457.33
0.33.
square units. Now that right there is a test question. And the reason I'll ask a symmetrical is because it's very important for you to learn about symmetrical. And you don't do all the work, you work with your brain and you multiply it by 2 instead of doing all that tedious work. All right. That's a good test question. Next question. And this is 5.2. 5.2. 45/8. First of all, is it a test question? Probably not. Yeah, this is a see how many numbers you can see, how many boxes you can count, and then let's see if we can use geometry. And then we'll try to do the yeah, that we can do that too. From 0 to 4, we can do that. So I'm going to do by eyeball first. And that's going to be 1, 2, 3, 4, 5. 1, 2, 3, 4. So that's 20 blocks right here. 21, 22, 23, 24. 25 with that one. 26 with that one. 27 with that one. I would say 27.8 if I counted right. 27.8. Now we're going to use geometry. And geometry, we've got a rectangle. We've already done that. It's 5 by 4. 1, 2, 3, 4. 5 by 4. And that gives me 20. And then 1/2 base is 2 times height is 1, 2, 3, 4, 5, 6, 7, 8. Y'all check me. I believe it's 8. Half of 16 is what? 8. I got 28 there. So now let's do the calculus. Okay, what is the integral from 0 to 4 of 5 dx? Well, that's going to be 5x evaluated at 0 and 4. And 4 times 5 is 20. And then let's do the other. 4x minus 3. Antiderivative of 4x minus 3 from 0 to 4. The antiderivative here is 4x squared over 2 minus 3x, evaluated at 0 and 4. And we don't have to worry about 0 because it goes out. So this is 2x squared minus 3x. So 2 times 4 squared minus 3 times 4. And 2 times 16 is what? 32 minus 12. Wait a minute. No, it's not from 0 to 4, from 2 to 4. Okay, so I'm still doing 4, so let me do 4. 4 is going to be 32 minus 12 is what? 20? Yes or no? No, shoot, I messed up. Yeah, 20. That would be 20. Now we got to do 2. 2 squared is what? 4. 2 times 4 is 8. Right?
Yes.
I'm doing 2, yeah, 8. And then what's 3 times 2?
6.
6.
6, right? So 8
Yes.
minus 6 is what?
2.
2.
Well, I got 22, but I think there's something wrong. I got 22 right there. Here I got 27. They're 28, and they're 28. I think I've done something wrong here. The 5x, the 5dx. Okay, there it is. Okay, I see where I'm wrong. Let me redo this one. I see I didn't read the graph right. Where does the rectangle go to? It goes from 0 to 2. 0 to 2 of 5x dx. See the straight line? 5 at 5? Or 5, sorry. And then it goes up from 2 to 4. And what's that? 4x minus 3. I had my numbers mixed up, sorry. So let's do this again. 5x at 2. And that's going to be equal to what? 10. And then this is going to be 4x squared. That's going to be 2x squared minus 3x, evaluated at 4 and 2. I think that's right. Let's see what happens. All right, so 2 times parentheses squared minus 3 times parentheses minus 2 times parentheses squared minus 3 times 2. 4 squared is 16. 32 minus 12 is 20. 2 squared is 4. 2 times 4 is 8. 8 minus 6 is 2. And that's 18. 18 and 10 is what? 28. So I think we got it at 28 square units. So again, you can do it by eyeballing, by counting the blocks. You can do it by geometry and algebra. Or you can do it after you get your numbers right. Sorry about that. From 0 to 2, that's this area. That's under 5. Y is equal to 5. That's a straight line. And then from 2 to 4, it's under 4x minus 3. I like that problem. I really do like that problem. I don't like it as a test question because it does all 3. Because you can easily round that to 28. I like that problem. That's a good problem. Okay, now, I need to tell you one thing before we get started on the new stuff. And that is your test right now. I'm assuming we're going to get 5-1, 5-2, 5-3, 5-4, 5-5, and 6-1. That's what I see us tested on. 90% of your test is going to come from these three sections. 5-3, I think, 5-3. Let's see. Which one is the power rule? Is it 5-3? I think it's 5-3, yeah. 5-3 is the power rule. 5-5 is substitution. And 6-1 is the area between two curves. There's 90% of your test right there. These are the three things that you need to be able to stay in second calc. Notice I didn't say pass. I said to stay at the beginning of the semester. You need to know these three sections. So I don't want to waste a lot of time going over the symmetry sections. You know, symmetry and being able to count blocks and being able to do length times width. All right, I don't need y'all to be, you know, worried about that. I need you to worry about the power rule, substitution, and finding the area between two curves. All right, so with that being said, up until today, you have been doing this. Antiderivative of 4x squared plus 3x minus 2 dx. The antiderivative of 4x to the 1/2 dx. The antiderivative of 3x minus 2 dx. The antiderivative of square root of x minus 2. No, the square root of x. Okay, dx. All right, these are all one terms. These are all power rule. You do this one, each one separately. This is 1/2, 4 to the 3/2 over 3/2. This is 3x squared over 2 minus 2x. And this is x to the 3/2 over 3/2. So these are all power rule. And then we want to throw some logarithms in there. Let me find my logarithms. Well, I had some logarithms to show y'all, but I can't find them, so I'll just make one or two up. The antiderivative of 1 over x dx is equal to the natural log of x plus c. The antiderivative of 1 or 7 over x is equal to 7 times the antiderivative of 1 over x dx. And that's equal to 7 natural log of x plus c. And you've got your cheat sheet that shows you these. And then one that just make one up. Antiderivative of 1 over x minus 5 is going to be equal to dx is going to be equal to the natural log of x minus 5 plus c. So you know your logarithms. You got your cheat sheet that I sent you yesterday and today that has logarithms on it. Okay, so these are not the power rule. These are just 1 over x is natural log. If you get something, basically this is du over u. If you have the derivative over the number, than its natural log. Okay? So, and that's what that basically is. Take the 7 out. You got u, du, sorry, u. What is the derivative of x? 1. So you've got du over u. And that's what you get. What is the derivative of x minus 5? 1. So you've got u, du over u is equal to the natural log. What about e to the x? Well, we talked about e to the x. E to the x, the antiderivative and the derivative of e to the x is what? What is the derivative and the antiderivative of e to the x?
E to the x.
E to the x. So if I give you the antiderivative of e to the 2x, I put my parentheses there to make you remember. That's going to be e to the 2x over 2. You got to take the derivative of what's inside. You got to use it. And if I had the antiderivative of e to the negative 5x, that would be e to the negative 5x over what?
Negative 5.
Negative 5. Again, this is not the power rule. These are just logarithmic and exponential properties, and they should be in your cheat sheet. Now let's get to substitution. Substitution is used when you have more complicated problems. And usually there's going to be some parentheses involved. Usually there's going to be some parentheses involved. Now we are going to drill the power rule and these trigonometric and these logs and these e to the x's for the next 2 or 3 days. That means Tuesday, Wednesday, and Thursday. We are going to be doing these things over and over and over. Why? Because if you don't know them, you might as well just not even take the Calc 2. So, with that being said, what's the first thing you do? Let me give you an example of a problem that you'll see like this. The antiderivative of 2x times x squared plus 4 to the 100th power dx. The first thing you do when you see a problem like this is you make sure you rewrite that's too light. Hold on, I don't have a red pen anymore. I got to go to Walgreens and get some more red pens. Rewrite with least complicated with dx. Okay, how many terms do we have in this integration problem? How many terms?
2 terms.
2 terms. Good job. So tell me what they are.
2x and x squared plus 4 quantity to the 100th.
Okay, that's 1 term. So I'm going to just highlight that all in one big block. And of course, the other term is what?
2x.
2x. Now, which one's the least complicated?
2x.
So I'm going to put the 2x over here. That's multiplication. So 2 times 3 is the same as 3 times 2. That's legal. So I'm going to rewrite this. And that's number 1. Rewrite it. Do calculus teachers tell you to do this? No. And I want to ask some of you people that's had calculus in another school and didn't do well, or another here. I'm going to ask you a question here in just a minute. X squared, oops, that's not black. X squared plus 4 to the 100th power, 2x dx. Okay, now I've rewritten it. Now what are you going to do? Well, I'm going to put this in red, even though this red pen is about shot. This is the most important part. Number 2, let U represent the most complicated. And it usually is going to have to do with parentheses. Usually. Not all the time, but usually. So somebody tell me what's in parentheses.
X squared plus 4.
So I'm going to take my green marker because I'm going to take the derivative of it. So I'm going to let U equal x squared plus 4. Therefore, du is equal to, what's the derivative of x squared plus 4? 2x dx. Oh my gosh. What do you notice about this? This says 2x dx, and this says what? (2x dx). Do you think that's supposed to happen?
Yes.
They are supposed to match. So we're going to take our red marker and we're going to draw, and they are supposed to match. Let me ask y'all a question. I'm gonna move this right quick. Let's go back to algebra. Let's go back to algebra for a second. Do y'all remember doing a problem like this? Put the cantaloupe in the refrigerator if there's a place for it. Do y'all remember doing this? 2x plus 3y is equal to 7, and 4x minus y is equal to 2. And what did I tell you to do on this problem? Look for an opposite what? Coefficient, and always what? Have the same equal coefficient. If you don't, then you force it. So what did I do? Multiply by what? 3 here, and that gives me 2x plus 3y is equal to 7, and then 12x minus 3y is equal to 6. Everybody remember doing that? Yes or no? Okay, so you're manipulating part of the problem to make it match, aren't you? You need to take that same mentality if this doesn't match. And we're going to do one when it doesn't match. We're going to do a lot of them. This one matches. So technically, I have the antiderivative of u to the 100th power du. Yes or no? What's u? X squared plus 4. What's the derivative of x squared plus 4?
2x dx.
So I have u to the 100th power du, right? So what's the antiderivative of u to the 100th power? u to the 101st power over 101, Hubert. And now what's the last thing I do when I'm using substitution? What am I going to do for that u? What am I going to plug back in there?
X squared plus 4.
So x squared plus 4 to the 101st divided by 101 equals c. Or plus c, sorry. Now, I can tell you right now that there are 2 or 3 of y'all going, and you don't know what's going on. All right, just let it soak in. After about the 3rd or 4th problem, you'll start to see it. But let me ask somebody, who in this class has had a calculus class at another school or this school, and you're retaking it for whatever the reason? Anybody want to volunteer that? Okay, Mr. Wooten, do you remember doing this in that class?
Yes, sir.
Now, I bet you a $100 bill. They didn't show you like that, did they?
He didn't, but I found the pattern and it just made sense.
Yeah, but did they show it to you?
No, he didn't show it to us. He just
They don't show it to you.
us.
I'm showing it to you right here. Okay? Anybody else? They can lobotomize you with the substitution. Oh, and another thing, don't look at the book in 5.5 unless you want to be lobotomized. If you want to be lobotomized, then you go ahead and look at the book. All right, let's
I
do
wanna be
the one
lobotomized, Hubert.
that doesn't match. What, Mr. Michelle?
I was just saying I want to be lobotomized, Hubert.
Okay. Well, look at 5.5. I guarantee you will be. All right, now I'm going to give you one, and it's not going to be equal. Antiderivative 4x, x squared plus 5 to the 3rd power dx. Okay, I want you to rewrite it. Since that's multiplication, you can rewrite it. 2 times 3 is the same as 3 times 2. So you can turn it around and put the 4x with the dx. And that's going to give me x squared plus 5, 4x dx. Everybody with me? Now you should all be able to do that. That's nothing involved there but commutative law of multiplication. So I'm going to take my green pen and my orange pen. What is u going to equal to?
X squared plus 5.
X squared plus 5. Somebody give me that derivative, please.
2x
2x what?
dx.
Dx. I've got 4x dx. So we quit and go to the next problem, right? Cannot be done. No. You got to force it. You got to manipulate it. How can we make a 4 look like a 2?
Divide it.
Divide it or multiply it by what? I don't like to use the word divide. Multiply it by what?
1/2.
Okay, so I'm going to put, as y'all know I like my colors, I'm going to put a yellow 1/2 right here beside this 4. Now I can't multiply something by 1/2 without contradicting it, or not contradicting it, but I got to cancel it out. So I've got to put a 2 out front. What is 2 times 1/2? 1. So I'm multiplying the whole thing by 1. And now we have 2 antiderivative of u to the third du. Because this right here is du because it is equal to 2x dx. So now, what is the antiderivative of u to the third?
U to the 4th over 4.
U to the 4th over 3.
U to the 4th over 4. Remember, whatever you do to this one, you have to go down here and do it. So 3 plus 1 on top, 3 plus 1 on bottom. And the 2 and the 4 do what? Cancel. So now you have u to the 4th over 2 plus c, and u to the 4th is x squared plus 5 to the 4th over 2 plus c.
Hubert, quick question.
Yeah.
What happened to the du again? I'm still a little confused again.
This right here is du. Hold on. My camera's froze. There we go. This right here is du. What's 1/2 4x? That's 2x dx. So this right here is du. So when you have u to the third times du, when you have a function, you raise it to the third power, and the derivative is right here, then you can use the power rule. This right here says use the power rule. That's what that says. So you might want to highlight that, highlight it in blue. When you get this, u du, you're going to see it more. When you see u du, that means use the power rule.
Okay, so by the power rule, it just canceled out?
No, this tells you, this says, okay, student, you've got u to the third du, you need to use the power rule to find the antiderivative.
Oh,
This,
okay.
yeah, this is like directions. This is
Okay.
directions. Okay, student, use the power rule to find the antiderivative of this by doing the power rule.
Okay, that makes sense. I was thinking that du was still dx dx.
No,
And,
no, du, that's why it's so complicated. It's easier here to show you the method before I show you why. And you don't want to. And if I tried to show you why before the method, you would be lobotomized. So it's better just to do it like this.
Okay, thank you.
All right. Let's do a nerd. Oh yes, let's do one that you'll quit on. Easy to quit. Antiderivative of e to the 5x minus 3 dx. Now I'm going to put something right here for you. Hopefully it'll help you out. There you go. Now you don't have to rewrite it because you don't have anything, in there except e to the 5x minus 3. I'm going to make a note here. Usually, you don't mess with e. Okay? Usually, when you are doing u substitution, the u is going to equal some form of x. Okay, you're not going to say, okay, u is equal to e to the blah, blah, blah. Oh, no. Usually your u is going to be in some form of x. Why did I put the pink parentheses there? Maybe give you a hint on what you need to do. So somebody tell me what u is equal to.
5x minus 3.
5x minus 3, good. Therefore, what is du equal to?
5
5 what?
dx.
Dx. Hey, I got dx, but I ain't got what? I ain't got no 5. So that means you just quit and go to the next problem, right? I put a 5 there. What I got to put out front? 1/5. And now I have 1/5 antiderivative e to the u du, because this is du, and this e to the u e to the u. Hey, what is the antiderivative of e to the u?
E to the u.
E to the u. So your answer is 1/5 e to the u plus c, and 1/5 e to the 5x minus 3 plus c.
Huber, quick question.
Yep.
So I understand how you found u, but how do you find du again? You just take
Always
the
take the
derivative?
derivative.
Okay, that's what I thought.
That's always, remember me taking the derivative in orange when we did first times the derivative of the second plus, when we did the product rule and the quotient rule, I would always write down the function in green and take the derivative.
Yes, sir.
That's what we're doing here.
Okay.
Just basic power rule. All right, if that one don't make you quit, let's do another one that'll make you quit. Eight cosine 4x dx. And I'm going to give you another hint. I'd rewrite first. Make sure you rewrite. All right, take off. I'm going to let y'all do this one. You might need your cheat sheet. The antiderivative of the cosine is the sine, but I'm going to let y'all use your cheat sheet. I sent it to you before class. I don't believe it. The stock market's up over 10 points. Wow.
Dogecoin went back up too.
Say again?
Dogecoin went back up too. Well,
Yep.
then
Let
back
me
down.
look right quick.
It's
Ain't
on.
going up fast enough for me. It's 25 cents right now.
Yeah.
It was up this morning to 26 cents, but it's back down to 25. I want it and dadgum my other one, Shiba Inu, I want it to go up.
I feel like if I sell my Dogecoin, it's going to skyrocket.
It will. One day it's going to. I don't know when that day is going to come, but it's going to. I think it's going to go up to $2 eventually. It might even go up higher. Because with the politicians we got in Washington, dollar is going to keep on losing. It's going to keep on losing. You know, it's not going to be worth anything.
30%.
That's what happens when you put a bunch of politicians in charge of money and business. They have no clue because they've always been politicians.
Yeah. 30% of all the bills that we have in America were printed in the last year.
Yeah,
30%.
yeah,
That's ridiculous.
yeah. Just print more money. That's all. You know. I'm not even going to get started. I was watching the Olympics. You know, I hardly ever watch it, but I thought I'd watch it, support America, and then a couple of dumbasses got on there and started doing stupid stuff. So I turned it off. I'm all for the people that are winning and acting like, when you get up there and you won a medal for your country and you do something stupid, you need to have the damn medal jerked away from you. If you don't like this country, go over to Iran and live in it. I'm sorry. Sorry. I'm a terrorist. Remember, I'm a veteran terrorist, so. I've heard this bull crap from these, and it's coming from people that's making millions and billions of dollars a year. Shut the hell up. I'm sorry. Buddy, when I came back from overseas and I came back from living in the desert for 9 months, I kissed the ground that I walked on in the United States of America. All right, shut up, Hubert. Let's go with the antiderivative of the cosine of pink parentheses. Hubert's giving you a hint. Oops, I wasn't supposed to do that. And then 8 dx. And I'm going to go over here and I'm going to make u equal to 4x. And du equal to 4 dx. I got an 8 dx. So what am I going to do?
Multiply by
I
1
want
half.
the 8 dx to be a 4 dx.
Multiply by 1/2.
1/2. And if I multiply the inside by 1/2, I got to multiply the outside by 2. And now I've got, and I just put a couple extra steps in here so you can see what I've got. I've got 2 times the antiderivative, the cosine of u du. So if I have the cosine of u du, then I can take the antiderivative of the cosine. That's all I need to do. And this is du. And this is cosine of u. So this tells me right here, take antiderivative of cosine and plug chug. That's what that says. Once I get u du, I need to take the antiderivative. So that would be the sine 2 times the sine of u plus c. Oh, now I've got an s there. Plus c. And that's going to be 2 sine of 4x plus c. Mr. Wooten, was it that simple when you took calculus
For
the rest of the class?
No, we did about this much in about 5 minutes, and then he kind of went off the rails and did other stuff. But
Yep.
Is it going to be about this simple for all your tests and stuff on this?
Well, they're going to get harder. Monday, Tuesday, and Wednesday of next week, we're going to do some more challenging ones.
Okay.
But but right now you got to put the training wheels on. You can't jump the ramp the first time you get on the bicycle.
Yeah.
You gotta get training wheels on. We're doing training wheels right now.
He sped through it pretty quick.
Oh yeah, you were probably jumping off the ramp the first hour, the second hour.
Inverse, cosine stuff on our third problem.
Yeah, you can't do that at first. That's like playing Beethoven's Fifth the first time you sit at a piano. All right, give y'all another one. Oh shoot, I'm gonna give you this one, and y'all can work on it. I've got plenty to go over for Tuesday and Wednesday. This was for one to go on, so you'd work on. X to the third, E, X to the fourth, and I'm gonna give you a hint. And dx. And I would move the x to the third, and then you can work it out, okay? All right, we'll finish that one. We'll do that one when y'all come back. Y'all got a long weekend, and I've got a long weekend, and I'm going to enjoy it, and I hope y'all enjoy it. Y'all get out of here and have a good, long weekend, okay?
Thank you.
Are we not?
5.1 to 5.5. Be working on all of it.
Are we not meeting Monday?